Hello there. I thought that in this video we could find the antiderivative, or the indefinite integral, of this function x over 1 over the square root of 1 minus x squared using trigonometric substitution. Now, trigonometric substitution is not necessarily the only way to solve this problem, but it's the one I'm going to be using because it would be good to get some practice. Now, the reason we go look straight at trigonometric substitution is because we see this 1 minus x squared down here. When you see 1 minus x squared, especially in a square root like that, that's kind of indicative of the Pythagorean theorem, and the Pythagorean theorem, of course, has a big role in trigonometry because of the Pythagorean identities, etc. So it tends to be an easy way to simplify things. So what I'm going to say is that x is equal to the sine of theta. Hence, dx d theta is equal to cosine theta, or dx is equal to cosine of theta times d theta. So, this is not like this step here, and I say this every time, this step here, it's kind of like you're multiplying both sides by d theta. That's not necessarily the superest mathematic, and superest is the word, by the way, the superest mathematical way to think of this, but I found that that's the clearest way, and for all of our intents and purposes, it will be accurate. Okay, so we have that dx is cosine of theta d theta. Now all we need to do is just make these substitutions. So for our integral with the substitutions, I'm going to change it to orange because orange is a nice color. We're going to have the integral of, x dx. What's that going to turn into? That's going to turn into sine of theta up here for the x, and times the dx, that's going to be cosine of theta d theta. Then we're dividing by the square root of 1 minus x squared, that's going to be sine theta squared. There we go. There we go. So let's just simplify this a little bit. We're going to have the indefinite integral of sine theta cosine theta over the square root of 1 minus sine squared theta d theta. And what's this down here? There's that Pythagorean identity. You should probably know by now that sine squared of theta plus cosine squared of theta is equal to 1, and hence 1 minus sine squared of theta is equal to cosine squared of theta. It's pretty important. That's not a theta, but whatever. All that stuff isn't that important anyway. You should probably know that. If you do not, maybe this is not the perfect video to watch, because that's used pretty thoroughly in calculus, the trig identities as such. So once we have this here, I'm just going to make that alteration. We're going to have the integral of sine theta cosine theta over the square root of 1 minus sine squared, which is going to be the square root of cosine squared of theta d theta. Okay, so now we're going to do a step, and this is going to become important in a moment. We're going to say that this is the integral of sine theta cosine theta over cosine theta d theta. That's going to cancel these out. We're going to have the integral of sine theta d theta, which is going to be negative cosine theta. Now, there's still another step we need to do. Let's go back to the top. X is equal to the sine of theta. Let's solve for theta. Theta is equal to the sine to the negative first of x. Okay, now here's where this step becomes important. Notice we took the square root of the cosine of theta. That doesn't necessarily give the cosine of theta. That gives the absolute value of the cosine of theta, because the cosine of theta can be negative for obtuse values of theta, right? Or, yeah. I'll stick with that. We're talking about second and third quadrant, right? So the reason that I didn't do this here is because it's not going to matter, because we're doing this step up here. The arc sine is assuming an acute angle. When we make this definition, because it's not a perfect inverse function, and if this is just kind of a bunch of gibberish, that's okay. I'm still going to get to the point. But the reason that we're allowed to say theta is the arc sine of x is because we're assuming that theta is an acute angle. Now, what if it was an obtuse angle, right? If it's an obtuse angle, our work up here is going to create a negative answer, and that's going to be clear in a moment. But if it's an obtuse angle, then we wouldn't actually, this step down here isn't actually going to give us because, this plus or minus thing, this is kind of a dishonest way of doing it, and it creates the absolute value of cosine theta, and we ignore the absolute value because our cosine theta is positive. We can ignore that stuff. But the reason we didn't do plus or minus is because we're assuming it's plus because the angle is acute. If it's not, then we'd have a minus, and in the end, we get these two minuses, and they cancel out. If that's a bunch of nonsense to you, it's okay. Just follow along. But I think that for those who are just a little confused about some of what we've done here, hopefully this clears a little bit up. Okay, so now what do we have? We have theta is sine to the negative first of x. So I'm just going to make a little graph here. Make a little triangle. This is our theta, and its sine is x. So why not just draw like that? That accurately represents the information we have. That theta is the arc sine of x. X over 1, right? That's a 1. So if we want negative cosine of theta, that's going to be the negative cosine of the arc sine of x. So if this is the arc sine, this theta here, if this theta here is the arc sine, then what's the cosine of it? The cosine is going to be this side down here over 1. What's this side down here? Well, we can just do the Pythagorean theorem. It's going to be the square root of 1 minus x squared. So this is going to be negative square root of 1 minus x squared. That's going to be equal to the negative square root of 1 minus x squared. And this is the indefinite integral of this function inside here. And of course, plus c. I'm not going to forget that this time. Hopefully that this was a little clear, and I'm just going to look back for a second and show you exactly what I was talking about the negative signs before. So basically, and I'm going to clear a little bit of this up because it's kind of messy. So what I was saying before is that when we take the square root of cosine squared theta, let's say that, this square root, in reality, in what we're thinking of, let's say we get, we could say plus or minus cosine of theta here. That's not how this is being used, and that's because here, if you look at the triangle, this triangle just represents cosines. Cosines can be negative, so there's no reason that this triangle couldn't be flipped the other way, and that this would be negative 1 minus x squared. But notice, then we'd have negative, but also another negative times here, and those negatives would cancel out. So all the negatives in the end cancel out. This is just adding a bunch on. My point is, this is the antiderivative. If, for whatever reason, using the arc sine seems a bit iffy, just think about how, if we had an obtuse angle, some other steps in the proof would also have to change. And in the end, we get the same answer. I hope that that's not too confusing, and thanks for